Alright guys, so today we're going to take a look at piecewise functions. Once again, just another different way to look at them, answer a couple questions, and we'll move on for the day. So, the first question I have is, I want to graph this function given here. Now, if you guys want to follow along, this is chapter 4, lesson 12, question 4, piecing all together. This one comes directly from there. So, if we have our input value, now remember, if this is our function f, these are all of our input values, which makes these all of our output values. So, if our input is between negative 10 and 5, so we can count out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If it's between negative 10 and 5, which is right there, then our output value, the y value, has to be negative 5. 1, 2, 3, 4, 5. So our line's going to look close to this. Now, what are our ends going to look like? Normally when we draw straight lines, they have either arrows at the end. When we were doing inequalities a couple years ago, they always had dots or open circles. Now, we can tell if they're going to have open circles or dots by looking at the inequality symbols here. So if you remember that, if it's just greater than or less than or greater than, then we're going to have an open circle. And if it is less than or equal to or greater than or equal to, we're going to have a closed circle, or closed dot. So for this one, the first part here, we have open, strictly less than and strictly less than means we need open circles on both ends. So open, that's not looking good. Open and open. Great. Now about the second equation here, the second part of our piecewise function. Well, if our inputs are between negative 5 and 0, between negative 5, which is just where we left off, and 0, then our output is going to be x. Well, if I remember how to draw a line with my slope here is 1. I can kind of work backward. And my line's going to look something like through that point, through that point, through that point, and that one, right to there. Now, on this end, at the negative 5 end, I need a closed circle. And if these are going to overlap, that's perfectly fine. You can have an open circle and a closed circle at the same point if those 2 points cross over each other. And the closed circle is going to take priority. It just happens to be that if you put in negative 5 into this equation and this equation both overlap each other at this coordinate. So we can just put a solid dot there. And on the other end, when x is just less than 0, we need an open circle on that part. All right. How about this next piece? If x is between 0 and 3, my output should be at 1. So if x is between 0 and 3, output's going to be 1. So I need it between there and there. Now which ends need closed circles and open circles? Well, this end I need a closed circle. When x is 0, I need a closed circle. Put a closed circle there. And when at this end, when x is 3, I need an open circle. Because if x has to be less than 3. So here, these two lines don't overlap, so they're going to be two separate points. All right. Next one, this one. All right, it's getting a little harder. If x is between 3 and 8, I want the line x minus 2. Well, there's a couple ways we can do this. I'm looking between 3 and 4, 5, 6, 7. Between 3 and 8, so I want my x values to be somewhere in this range. Now, how am I going to graph this line? Well, there's a couple different ways. And I'll show you both different ways we can do it. The first way, going back to Algebra 1, I can make a T-chart. Plot a couple points, connect all my dots together, and get a graph. Let's try that out. My inputs, my x's, my outputs, my y's. Remember, I'm looking specifically at this line right here. Well, if I input, well, I need to start with somewhere, so let's start with 3. Now, it doesn't matter which values we choose. To get the points for our graph, to be able to draw our original line, I can use any values I want. Then I can shrink my window down. So, let's start with 3. If x is 3, and I can plug it into my equation here, 3 minus 2 gives me 1. Let's try 5. Let's try and jump a couple points here. If I substitute 5 in here, I get 5 minus 2, which is 3. All right, let's try 7. I'll substitute 7 into our equation. 7 minus 2 is, that'd be 5. Well, it looks like I might have enough points to try and start graphing my line here. So I have the point 1, 2, 3, comma 1. I'm going to need that point. Gee, different color for now, real quick. I need that point. I need 5, comma 3. 1, 2, 3, 4, 5. 1, 2, 3. Need that point. And 7, comma 5. 7, 5. Then I can connect all my dots together. Now, I could connect all of the dots together in a big long line just like that. That gives me what the line x minus 2 looks like. But remember, I'm trying to restrict my domain. I'm trying to limit the number of inputs I have so that it is only the x values between 3 and 8. So I can actually do between 3 and 8. My line just like that. Now, what ends are going to be open? What ends are going to be closed? Well, on this end, when x is 3, I need a closed dot here. And look, they overlap again. So the closed dot is going to take priority. And on this end, when x is 8, I need an open circle. All right, last one. When my inputs are between 8 and 10, my output is going to be 6. So if x is between 8 right here and 10, my graph is going to be, my output is going to be 6. Over to 8, up 1, 2, 3, 4, 5, 6. It's going to be that line. And again, we need to figure out which ones are going to be open, which ends are open, which ones are closed. On this end, when x is equal to 8, we know that's going to be a closed circle. Now when x is 10, it's got to be an open circle. All right, let's take another look at the second problem here. So this problem comes from one very similar to what you guys will find on your homework assignment tonight. And again, we have our new colors. These are our x values, our inputs, our domain, and these are our outputs, our y values, our range of our function. All right. So when x is between negative 15 and negative 10, now it looks like the scaling on this one's a little bit different. Let me add it in. All right, that's better. So each of these blocks are going by 2 units instead of 1. So if our input's between negative 15 and negative 10, well, that means we're just looking at between negative 15, which is right, negative 15 right here, and negative 10, which is right there, right between negative 8 and negative 12. That means we're really looking at this little segment right here. This line corresponds with this line up top. And there's no blanks, so we're not looking for anything for this piece. The second piece, however, has us missing, we are missing the output of our function. The next one, between negative 10 between negative 10 and negative 8, which is this range right there, this one, our output is always negative 8, which means I can take my negative 8. I'm just going to go right there. All right, next one. It looks like I'm missing one of my inputs. So let's take a quick look. If my input is between some unknown number and negative 1, so some unknown number and negative 1 right there, my output is going to be negative 6. Well, I can go down 6. 1, 2, 3, 4, 5, 6. So it looks like we're talking about this little segment right here. Well, where is this line going to start? So I'm missing my starting value. Well, I'm starting at my input of negative 8. Which actually matches where the last one ended. This one is just starting back up again. So this one ended at negative 10. This one started at negative 10. This one ended at negative 8. This one's starting at negative 8. This one's ending at negative 1, starting at negative 1. So most of the time, not always, but most of the time, these lines tend to, one piece of our function ends, of our piecewise function ends, and it starts right from there. All right, let's take a look at the next question. When x is between negative 1 and 4, we're missing our output. Well, if x is between negative 1, which is right there, and 4, 1, 2, 3, 4, x is between negative 1 and 4, my y values, oh, this one looks like we're talking about this part of our piecewise function right here. However, this has a slant, but it looks very similar to an expression that we did earlier. Looks very similar to an equation on a function that we talked about earlier. Actually, looks like it has the same slope as this one. It's going up 2 over 2, up 2 over 2, up 2 over 2. It's going to have a slope of 1. Just trying to figure it out here. Y equals has a slope of 1. X plus, what's my intercept? Well, my intercept is wherever it crosses my y-axis, and it's crossing right at 0. Which, hey, I can simplify this to just y equals, well, 1 times x is just x, plus 0 is plus nothing, it's not going to change. So all I have to do is put an x right there. Y equals x. My function equals x if my input is between these 2 points. All right, next one. Looks like I'm missing my input values, but I know my output is going to be negative 4. So my output is -4, means it's going to be right there. Well, the only spot that this function is equal to -4 is between these 2 points right here, between 4 and 10. If I'm between 4 and 10, my output has to be -4. And my last piece is already given to me. If my input is between 10 and 15, it's between 10 and 15, my output has to be at 16, or 18, between these 2 points.